Hi everyone, this is Babaiah, Assistant Professor of ECE Department from MLR Hyderabad. Today I am going to explain about the order of the system. Let us move on to the overview of today's session. Just observe the first point is what is the meaning of order of any system and also some of the examples of the order of the system. Now we are going to see all these points. Let us first one is just order of the system. What is the meaning of order? Generally we say that the maximum power of the any differential equation is nothing but the order of the system. Simply we say that the maximum power of the any differential equation is nothing but the order of the respected system is known as the simply order, right? Here just I am going to consider one input and output relation equation. Just I am going to here explain just to see the input. I am going to consider input is Q of t. Here see, observe, Q of t is my input, or another name for the input signal is the excitation signal, and as well as the output is here P of t, or another name for the response. The input is Q of t and output is P of t. Now I am going to consider one differential equation, that is the nth order differential equation. Just to see here, a naught d power of n by dt power of n and p of t, where is the p of t is nothing but the output or response of the system, and here a naught, a1, a2 and so on, all these are the coefficients of the differential equation. Here n d power of n, it is the nth order differential equation, and here n next coming to the n minus 1 terms, n minus 2 terms, n minus 3 and so on, n terms, n minus n terms. So here just n minus n is directly 0. So here the d by dt of p of t, and here plus an p of t, d power of 0 by d for dt power of 0 is nothing but the completely value is going to be 1. So directly an into p of t simply. Okay, this is the input, this is the output equation, that is equals to input equation is I am going to consider the coefficient is b naught for the output relation. For the input relation b naught d power of m by dt, m terms I am going to consider here m terms of output and n terms of input. Just here b naught d power of m by dt term, as well as b1 d power of m minus 1 by dt power of m minus 1 and q of t, like that and so on. Bm q of t, bm coefficient and q of t is the input. This is the input sequence, and here output, the output is equals to input. In that consider, now I am going to arrange the output to the input ratio, that is the equation, or else that is the transfer function of the any system. Here q of t is the input and p of t is the output. Just the output, the ratio of output to the input is nothing but the transfer function of system. Here same, the order of the system is given by the nth order differential equation governing the system. Here nth order differential, here nth order differential equation, if the system is governed by nth order differential equation, then the system is called as nth order differential equation, or else nth order system. Simply we say that. Here we are consider here nth order differential equation, so the order is nth order simply. Okay, coming to the next here, just observe the transfer function of the given equation, differential equation. After applying the Laplace transform, this time domain equation is transferred into the Laplace. When we are going to apply the Laplace transform, the time domain is considered as the S domain. S domain equation, here observe, the order can be determined from the transfer function of the system, right? Transfer function of the system, by using transfer function we are going to calculate the order. So here the transfer function is nothing but what? The output, the ratio of output to the input here. Output is the P of t, or input is the Q of t. Then we are going to apply the Laplace for the time domain equation, that is considered as, that is transferred into the, converted into the S domain function. Here observe the transfer function T of S is equals to P of S is my output and Q of S is my input, that is equals to b naught s power of m plus b1 s power of m minus 1. Here just to see, after apply Laplace transform, this term is going to be directly a naught d n by dt power of n, that is nothing but s power of n. This is the P of S simply. Okay, like that we are going to convert this equation into the S domain. Here b naught s power of m plus b1 s power of m minus 1, b2 and so on. Next here in denominator polynomial also, a naught s power of n plus a1, this equation is comes from the previous differential equation in terms of time domain to S domain. This is our equation, that is the transfer function of the given differential equation. Here see, and P of S is the numerator polynomial here, and denominator polynomial is nothing but the Q of S. For a transfer function denominator polynomial, consider as a calculation for the order of the any system. Here the denominator polynomial is what? Here denominator polynomial is nothing but the Q of S is equals to this term. Denominator is a naught s power of n plus a1 s power of n minus 1 and so on. Like so, this equation I am going to consider to calculate the order of this system. Here Q naught equals to a naught s power of n plus a1 s power of n minus 1 and so on. Here the maximum power is nothing but s power of n. N is order of the system. Then we say that order of the system is n. For example, I am going to consider n equals to 0. N equals to 0, then the system is going to be 0th order system. Here observe, 0th order system. Here if you are going to substitute in place of n 0, s power of 0 is equals to, here n equals to 0, so 0 order system. So there is a no s terms are available in given equation. When we are going to apply the n equals to 0, in that condition we are going to get the order is 0 order system. If we are going to n equals to 1 substitute in the denominator polynomial equation of the transfer function, this transfer function denominator polynomial is Q of S, that is equals to a naught into s power of n plus so on. So for n equals to 1 condition, the order of this system is going to be s power of 1 here. A naught to s power of 1. In place of n, we are going to write the 1. So s power of 1 is nothing but the 1 is the order of that respective system. Next coming to n equals to 2. If I am going to substitute n equals to 2, the order of the system is going to be second order system. And so on. If we are going to substitute n equals to 3 or n equals to 4 and so on, the system is going to be order directly increasing by based on the n value, that is the maximum power of s. Here maximum power of s power of n. If you are going to n equals to 0 or 1, 2, so on, the order is going to be increases by applying the n equals to value, some any value order, that is indicates the order of the respected system. But order of the system can be calculated both the open loop systems as well as closed loop control systems. We have two types of systems are available in control system, that is open loop control system and closed loop control system. In previous first unit we learn this topic. So here the open loop and closed loop control system, these two are, by using these two systems also we are going to calculate the, or we are going to determine the order of this system. It is possible for open loop system as well as closed loop control system, right? Next here see, observe the denominator or numerator polynomials. Just we are going to factorization method. When we are going to use the factorization method completely, here transfer function T of S is equals to P of S divided by Q of S equals to Here after factorization, here simply just observe b naught s power of m, s power of m minus 1 and so on. Here n term and m terms, n terms and m terms. Here s plus z1 and s plus z2 and so on. All these are the numerator terms. Numerator terms of the transfer function indicates as the zeros of the system. Zeros of the system. So here s plus z1, z2, so on, zm, m terms in numerator and n terms in denominator. S plus p1, s plus p2 and s plus so on, s plus 3 and so on, s plus pn. This is the denominator polynomial. Denominator polynomial of transfer function indicates the poles of the system, and also the poles of the system also gives the information about the order of the system. Simply here see, now the value of n gives the number of poles in transfer function. Is n represents the number of poles present in the given transfer function. That one is indicates also order of the system. Here order is equals to poles. If we are going to say the directly, order is equals to poles. After factorization of the S domain function, just s plus z1, z2 zeros by poles. If any transfer function is available, zeros are available, zeros and poles are available in any transfer function, the denominator part, that is the poles indicates as the order also can be determined by using the poles of the system also. Okay, this is the important point. Next, some of the examples here. The examples of the order of the system. Generally order of the system is nothing but what? The maximum power of the s, right? Maximum power of the s term, that is s power of n, n plus in n plus we are going to substitute 0 or 1 or 2 so on. Okay, that is indicates the order of the system. Here simply some of the examples. The examples order can be determined by using the open loop as well as the closed loop, right? Here now I am going to consider the some open loop transfer function g of s, that is equals to s into s plus 1 divided by s square and s plus 2, s plus 3, s square, s plus 2 and s plus 3. Here s into s plus 1 in denominator part, just observe the denominator part. This denominator part indicates the poles and numerator part indicates the zeros of the transfer function. Zeros of the transfer function. If s into s plus 1 by s square into s plus 1, s plus 3, for example. Here s is there, s square is there. S and s square both just cancel. Just solve this one. S plus 1 divided by and s into s plus 2 and s plus 3. S plus 2 and s plus 3. Just here observe. How many poles are available from the given example? Just 3 poles are available. S equals to 0 pole, s equals to minus 2, s equals to minus 3. If it is going to be equating to 0, we will get s equals to 0, 1 and s equals to minus 2 and one more is s equals to minus 3. Right, here zeros are s equals to minus 1 only. Here order of the system is nothing but maximum power. How many s terms are available here? S power of 1, s power of 1, s power of 1, completely s cube. So this example of this one is the order is equals to 3, third order system. We simply say that third order system. In denominator part, the maximum power in denominator polynomial transfer function, the maximum power of s is indicates the order of the system. Simply. Okay, this is the one example. Next, coming to the second example, just I am going to write here. The transfer function g of s is equals to s divided by s into s plus 1, s into s plus 1. The order of this system is nothing but order is equals to maximum power, right? Maximum power. So maximum power is nothing but here s term is there, s plus 1, one more s, total square, s square. So order is 2. second order system, this is the third order system. For example, one more example, g of s is equals to s divided by s into s plus 2 and s plus 3, and here this one is s plus 2, here s plus 3 and s plus 4. Here s plus 2 divided by s into s plus 1. S into s plus 1, just observe here s and s square. So second order system. Next, coming to this example, here s into s plus 2, s plus 3, s plus 4. S plus 4, here just I am going to remove this s plus 1 divided by s into s plus 2, s plus 3, s plus 4. Order is just how many s terms are available? 1, 2, 3, 4. So s power of 4. S power of 4. Maximum power is equals to 4. So order is equals to 4. Simply we say the maximum power of s equals to order. So that is equals to 4 here. The given example. Like that we are going to determine the order of the respected system. These are the some of the examples to determine the given system order. Given system order is just the denominator polynomial is nothing but the poles. The poles also gives the information about the order of the system as well as the maximum power of the s term, that is the transfer function denominator part. This is the denominator polynomial or denominator part. The denominator part indicates or it gives the information about the order of the system. Order of the system is generally the maximum power of the s. Simply this is about the order of the system and how to calculate the order of the system and how to write the some examples, how to determine from the given transfer function the order of the system. Just all these are the order of the system examples. Next here, this is about the order of the system, right? Order is nothing but what? The maximum power of s term. Maximum power of s is nothing but the order of the system. And also order of the system can be calculated for the open loop systems as well as the open loop control systems, both. And also here the denominator polynomial of the transfer function always gives the information about the order of the system, right? And also poles also gives the information about the order of the respected system. This is the order of the control system. This is very important topic, right? I think you understood all the points. These are the very important key points for order of the control system, right? Thank you.